Good morning, everyone, and welcome to Manitoba Agriculture Crop Talk webinar. If you have any questions during the presentation today, please type them into the Q&A icon on your Zoom toolbar, and we'll get to them at the end of each presentation. This webinar is being recorded, and you will receive a link to the recording. Thank you.
Thanks, Lori. I'd like to welcome everybody to the October 1st edition of Crop Talk. And boy, has the year gone by fast. We're into October and we're seeing the end of harvest. A lot of areas had a really good week this past week, and a lot of producers were able to get a lot of crop off. So I could see where a lot of those acre numbers or percentages complete are going to be a lot higher when the crop report comes out later this afternoon. But yeah, so as we get harvest done and talking to producers, there's a lot of more producers talking about getting ready and getting prepared to do fall work and get ready for the 2026 growing season. So I thought that we know when we go through the growing season, we always talk about the importance of soil sampling and getting all that kind of stuff done. And as it's an important tool for saving you money and stuff, I thought it'd be a good idea to get Marla to come on today and to talk about the soil test sample results that you get back and what do they mean, how to read them, what to take from them as you go ahead to plan your fall fertilizing and right through to spring cropping decisions. So I guess with that we'll start with Marla, and then after she's done we'll get to a few questions. So Marla, if you'd like to grab the screen here.
You bet. Can you see everything there okay?
You bet.
Awesome. Okay. So yeah, thanks, Lionel. It is that time of year when we are very actively soil sampling as crop starts to come off, and it is a good time to talk a little bit about those soil samples, what that soil analysis looks like, and specifically what we do with that information or how that information ends up being used, what we're looking for. There we go. So soil testing specifically is designed to measure what is available in the soil to be able to feed, say, next year's crop if you're doing this in fall right now. And so we're predicting fertilizer requirements based on that plant available nutrient. We're not always, depending on the nutrient, looking at the total amount of nutrient in the soil, but essentially what can we expect will be able to come out of that soil or out of the soil essentially to feed that next crop. So some of the critical things that we're looking at when we're coming up with a fertilizer requirement is the crop requirement, what that needs, the soil supply, which is what we are looking for in that soil test. And then we're also considering that fertilizer use efficiency, and that's what's going to come up with that fertilizer recommendation. It's a good thing to note that soil testing or the analysis that is done by the lab is just looking at the soil supply. A lot of the labs will give you a fertilizer recommendation that comes along with that analysis. The lab themselves are not creating that fertilizer recommendation. The fertilizer recommendation is usually coming from elsewhere. It's coming from other research that is, been done in the region that is relevant to the area that you are farming in or the area that that lab is in. And then that's what they're kind of assessing, essentially the soil supply, and then coming up with that recommendation out of that. So the testing part and the analysis, that is the lab's focus. So we need to know then a number of things that are very field specific. We need to understand the crop nutrient requirements. We need to then know what crop we're growing, what that target yield is. And then we want to consider, the environment, the soil type, the crop species or variety. Sometimes we can adjust things a little bit from there. Again, and those yield potentials and goals that we are trying to achieve, that will give us a better idea then of what the nutrient requirement will be in order to achieve said nutrient or said yield goal. We want to know the soil's power to supply the nutrients, and that is what the soil test analysis is looking at. And then we also consider fertilizer use efficiencies. So when we talk about things like, say, nitrogen, let's say, if we were broadcasting in fall, that will have a lesser fertilizer use efficiency than if we were, say, banding in fall, or broadcasting in spring, or banding in spring, based on the potential loss. So we recognize that there is some loss potential with that fertilizer that factors into the fertilizer use efficiency, and that will then potentially work its way into those fertilizer recommendations. It's important to just make a couple comments around the soil sampling itself that we're doing at this time of year. Sampling frequency is often something that we talk about. We recommend annual sampling because of the fact that some of these nutrients can change very quickly or change a lot from year to year. Things like nitrogen and sulfur are mobile in the soil, they move with water. And so they can kind of come and go a little bit within that plant or within that rooting depth, that top 2 feet. So if it's nitrogen, let's say we've followed a drier year, we haven't used as much of the nitrogen fertilizer that we have put down, we may have more available there for the next year. And so that because of that, we like to have that annual sampling frequency just to make sure that we're not over applying or under applying based on what is there from year to year. Theoretically, periodic sampling is okay, especially if we're talking about nutrients like phosphorus and potassium that don't move in the soil. But we need to then be taking into account crop yield, crop removal rates to understand what that balance looks like. So if you're working with an agronomist or you do periodic soil sampling, you're probably then also looking at crop yields, crop removal rates, and doing some budgeting from year to year to figure out whether or not you're targeting where you should be targeting based on those removal rates. So we want to look for trends in those cases to track what's going on if we're not testing annually. The other thing about soil testing is that variability is really big when we come to soils, and even on flat land. This photo on the right-hand side here from Enter Agronomy, it is looking at a Red River clay. This is flat land, but also just recognizing that where the soil was scraped, you can see variability in terms of how much, like where that topsoil ends, where there's kind of vertical cracking, where the soil has opened up and allowed more topsoil down into those cracks. And so depending on where you stick your soil auger or your soil probe in that area, you can get a different result because you're either tapping into soil, subsoil, or you're tapping into topsoil that's kind of fallen down into those areas. And that can vary greatly. So we recognize that variability means we need to take 15 to 20 samples per area or per field and mix those together if we are doing composite sampling. If we are doing sampling that looks at zones, you are looking at different zones typically based on landscape changes. And you are going to then sample, those eroded knolls that are in the photo on the left. Separately than those low-lying areas that are a little darker in color because there's more organic matter, there's more moisture down there, and the crop growth potential will be different. So you're sampling those areas separately and mixing them or keeping them separately for analysis. But even within those zones, you're taking 15 to 20 samples in order to manage for the variability in there. So some nutrients vary greatly, and the more samples you take, the more you can capture some of that variability. Sampling depth is really important. There's a reason why we recommend 0 to 24 inches for sampling depth. And so if you are doing the 0 to 6 inch sample, that first topsoil sample we look at, that's where we look for phosphorus, potassium, and the micronutrients. The reason for that is because those nutrients tend to be biocycled towards the surface. So they're taken up by the plant. The plant residue is kind of recycling that back into the soil. And if we till, we're only ever tilling really to that depth of about 6 inches. So because of that, when we till that in, we're mixing those back and keeping them just in that top 6 inches. These are also nutrients that don't move, so they're not going to leach down out of that top 6 area. Top 6 inch area. So that's why we sample for those nutrients there. And then we go to the 0 to 6 plus the 6 to 24 inch depth if we're looking for those nutrients that move with water. So things like nitrogen and sulfur, including chloride, will get it analyzed to that depth because they will move. And so we want to be able to see whether they're leaching down. And if you're only soil sampling to the top 6 inches for things like nitrogen and sulfur, you can grossly underestimate how much nutrient is actually there because of the fact that there can be a fair bit of that in that 6 to 24-inch depth. And that is within that root zone. So we expect plants to be able to take that up in that future year. So when we look at the soil analysis, we're usually just looking at a gauge, and you'll see this on your soil test where they may have kind of a low, medium, high range. And that's just a general gauge in terms of what the lab is looking at and whether or not you're in kind of a full tank scenario. If the tank is, sitting on empty, that's generally what they're looking at is where are you within this range so that you have a general idea of what you might want to target to increase. It's not an absolute measure of pounds per acre for all crops. For nitrogen, they may be telling you how many pounds of nitrate there is in the top 24 inches, top 2 feet. But with phosphorus or potassium, it might just be a supplying power of what you expect as opposed to the total amount of nutrients. So how much potential supply is there in that gas tank? So with the analyses for nutrients, we're looking for those macros, NPKs, as well as micros. The soil test is also going to tell you organic matter, carbonates, CCE, salts or electrical conductivity. It will look at cation exchange capacity and potentially base saturation as well. So these are different pieces of information that we need to be aware of if you do a complete analysis that gives you an idea of essentially what your soil does or what your soil potential is going to be. So we may not think of, say, carbonate, CCE, or salts, electrical conductivity, as being something that is very important, but because they can impact crops' ability to function in the soil or to grow and flourish in the soil, we do need to have a general idea of what's happening with those. Cation exchange capacity is usually something that is just estimated, and that's estimated. It can give you a general idea of what your soil texture is potentially if you don't already recognize. So the higher the clay content, the higher the organic matter, the higher the cation exchange capacity. But this can be inflated by having high amounts of free lime. So it's something that we take into account, but we also take it with a grain of salt, because it may not mean a whole lot to you in the grand scheme of things, especially if you have higher amounts of carbonates or salts in the soil that are throwing that number off. Base saturation is one that I get a lot of questions about. A lot of times we hear about base saturation in terms of using it to kind of analyze nutrient release or nutrient potential. But it's really important to note that when they look at the science of things like base saturation, the only times that ever actually comes into play is if you have acidic soils. And we in Manitoba don't tend to have acidic soils. Our soils are more in the neutral to alkaline range. So base saturation is not something that you have to look at on that lab analysis, again, unless you are dealing with a very acidic soil. So the recommendations that you'll see on your soil test, again, are going to be something that the lab is borrowing essentially or using based on research that has been done in the area that you are working in or the region that you're growing your crop in. So they're looking at potential crop yield that is correlated or calibrated to these soil test levels based on many, many years of research. These yield responses are usually depicted as a curve. So the top graph here again is nitrogen, and nitrogen is fairly easy to predict. You have, your nitrogen fertilizer added, you assess how much soil nitrate you have, you add those two together, and based on the understanding of how that crop will respond in yield increase, they're able to say this is the line, and if you get to this point, then that's what you want to do in order to hit this, whatever your yield potential or yield goal is. Phosphorus is something very different. That is a probability. And so on the bottom of the screen here, you see it's data from Wesco Regis Karamanos had been working on. There's 47 site years across the Prairie provinces, and this is looking at how crops respond to phosphorus fertilizer addition. And essentially, when you're in this kind of 11 to 20, like 10 to 20 parts per million of Olsen test phosphorus in the soil, you have about a 50-50 chance of responding by adding more phosphorus fertilizer. So phosphorus is very different in terms of how we look at it, and it's all based on a probability of response, which is why we don't have just this specific yield curve that you can say, okay, I have this much phosphorus, I want X yield, I'm going to add this much more, and I'm going to achieve that yield. It's just not how phosphorus works. Phosphorus is all based on a probability of response. So quickly going through some of these soil properties, I'm not going to talk about all of them, but these are ones that can affect soil productivity. I'm going to focus in on pH quickly, salinity, and CCE. These are things that you want to look at on your soil test because as they change or shift, or maybe they change or shift, they can change or shift potentially, and they can then influence that crop productivity. Sorry. So soil pH is important because it gives you an idea of general productivity. Typically, our soils are in that, we want our soil to be in that 6.5 to 7.5 range. That's where soils are usually the most productive. Where this comes into play is in nutrient release, essentially. So phosphorus is most available when your soil is around that neutral pH of 7. As it gets up in that 7.5, 8, above 8 range, it starts getting tied up with calcium more in the soil. And if it's in a low pH, it gets more tied up with aluminum. So we like to see a soil around neutral because it allows for more of those things like phosphorus, microbes, that sort of thing, micronutrients to be available. But we recognize that sometimes we can't control that soil pH. If we have a more acidic soil, we may be able to increase that pH with lime. But as we're looking at the soil pH, we want to recognize that if we are in an area like a high pH, let's say, where phosphorus availability or phosphorus fertilizer might be tied up, that means that we want to band that phosphorus so that it decreases the impact or connection that there is with the soil. So there's a lesser of a chance that it'll get tied up or bound up tightly with that soil. We can see soil pH change, especially if we have sandier soils that fluctuate a little bit easier. If we have, a lot of nitrogen fertilizer being added, we may have some acidifying that happens over time with that ammonium-based nitrogen fertilizer. We also might see changes in soil pH where the pH increases. You get more, high pH soils where if you're getting deeper subsampling or you have erosion where now you're losing the more neutral pH on the surface and you're getting into that alkaline subsoil more, we can see that change over time. So it's just something to keep an eye on around that sampling depth, but also whether or not on sandier soils that high nitrogen fertilizer is starting to lower the soil pH and get more acidic. And that's where you might want to be looking at liming to try to bring that soil back up again. Salinity is important because this one obviously impacts crop growth, especially things like soybeans and corn that are very, very sensitive to salinity. Salinity gives you an idea of the drainage or water movement through the soil. Typically, that high water table or poorly drained soils won't allow salts to flush down or leach out of that soil profile. So we want to be able to see what that salt is doing. And this is one where annual testing to 24 inches is really critical or very important to be able to monitor how the salts are coming up and down. Because if you get a salinity test, it tells you what's happening in that moment. But salinity fluctuates so much in the soil that you want to be able to track what's happening with that salinity from year to year. And so you want to be able to watch those trends happening. Again, it'll tell you which crops might yield well or yield poorly based on their tolerance. So we know that crops like soybeans and corn have very low tolerance. It doesn't take very much for them to start dropping back down and losing their yield potential very quickly. This is data from North Dakota State University, and they've kind of tracked EC tolerance or salinity effects on different crops. Whereas if you're growing things like wheat, barley, canola would also fit into that other grouping, where this crops can generally tolerate salinity for a lot longer, and it takes a while longer before that crop yield potential starts to drop off. I just note that I've changed the scale on the bottom. Most tests or most labs will do a 1-to-1 lab test. And so we have to take that number, which is the research number for crop tolerance, and divide it by 2, because that more accurately reflects what the lab test comparison might look like. So here again, if you are looking at a crop like corn or soybeans and you have a soil test that is nearing 1, let's go back, nearing 1 on the scale, it might not look that high, but for an intolerant or highly sensitive crop like soybeans and corn, that's all it takes for the crop to start being impacted yield-wise by that salinity. Sometimes I get questions asking about the types of salts that we find. So a lot of our salts are calcium sulfates. We also will have sodium-based salts. But again, sulfate-based salts and calcium sulfate, so that gypsum that's naturally occurring in our soils, that tends to be the thing that we see the most of. And so you may actually see high sulfate or high chloride on a soil test. And this, when I mentioned earlier, the variability within the soil test or variability in the soil, this comes into play specifically when we're talking about sulfate. We want to make sure that in a soil test, we want to stay out of potentially saline areas. If we're doing a composite test where we're mixing everything together to get a single analysis for the field. The reason being is that in a saline area, you could have, 14, 15,000 pounds of sulfate in that spot. And so if you accidentally mixed one of those into the rest of the field samples, that can grossly overestimate how much sulfate is in that soil. And so as a result, we want to be able to kind of stay away from that situation, leave those saline areas out. Sulfate can vary a lot, and we want to get the most accurate response we can, or analysis that we can for sulfate. But we recognize that because of this subtle change in salinity across the field, that sulfate will be maybe less subtle in terms of the impact and changes from place to place. We do have some soils that may have high sodium in them. They're not necessarily saline soils. They can be sodic soils. Or salinetic soils. It's not super common in Manitoba. If you do have issues with high sodium, you will then also have a soil pH that is over 8.5. And so then you have to get a special analysis called the sodium absorption ratio to truly understand whether or not you have a sodium problem. Sodium itself is not an issue. Unless you have more sodium than you have calcium and magnesium in the ratio we look for. And then that sodium starts to impact soil structure. So it's not actually a salt problem so much as it is a soil structural problem. If you have something that looks like that, then give me a call and we can work our way through it. Again, salinity is going to change with water. And so because of that, we want to look at this year to year, because we recognize that as water tables go up, or you have heavy leaching in following a dry year, a lot of rainfall that can move that down again through that soil profile. These things will shift that soil salinity. And so we want to be able to capture that information over time to watch how it fluctuates. The other thing we use salinity for is recognizing the potential for something like iron deficiency chlorosis in soybeans. Now, I mentioned earlier carbonates, that CCE, that is this level here. It's basically the amount of free lime that is in the soil. Because our soils are built on a lot of limestone, that's the reason why we have this high pH soil. We want to look at how much free lime exists in that soil profile. And that will then increase the potential for iron deficiency chlorosis. It doesn't automatically mean that you will have IDC show up. IDC will follow, say, wet or saturated soil conditions. So after heavy rains, we have issues with the crop's ability to take up iron based on these risk factors. So the higher the salts, the higher the carbonates, the more extreme that potential risk factor will be. It's a really important thing to note. If you have these risk factors, you know that you'll have a potential issue for IDC, in which case you want to figure out how you can manage those IDC potential, or like manage for the potential for IDC. That might mean better drainage of the soil. It may mean, and it should mean going in with a higher tolerant crop for IDC. So things to keep in mind when you're looking at that soil test. Okay, and then of course getting into nutrients. So this is kind of the thing that most people are questioning or looking at. Again, that we're looking for things like nitrogen and sulfur in that top 2 feet because they are mobile. They tend to be reported in pounds per acre because they are more closely analyzed in such a way that we can say, okay, this is the exact amount, let's say, that's in the soil. The immobile nutrients, so our phosphorus, our potassium, our micros, we're looking at those just in the top 6 inches, again, because they're kind of cycled towards the surface. That's where they're going to be found. Typically, they are reported in pounds per or parts per million. And the reason why is that they are only kind of giving us a supply power. It's not the total pounds that are there, but how much is generally available in that soil solution. And so that's why we usually look at them in parts per million. It's not possible to just convert that over. It doesn't exactly mean the same thing to convert it over into pounds per acre. So that's why we keep it in parts per million, because we're usually looking at that idea of probabilities as opposed to exact numbers when we're looking at recommendations based on these nutrients. So nitrate, this is most of our recommendations for crops are going to be, again, looking at total nitrogen requirement minus the amount that the nitrate has, because we know what those yield curves should look like. We can have a lot of variability in nitrate nitrogen. This is the reason why we want to look at these numbers on a regular basis. Annual sampling for nitrate nitrogen can be very helpful, especially if you're following a dry year, because we may have higher than expected nitrates. So, you know, the crop just wasn't able to take up as much of the nitrogen that we supplied to the crop. If we have warm, moist soil, we may have higher mineralization, especially if we had a lot of mineralizable nitrogen available with high organic matter in those areas. Also, did we set it too high a yield goal, and therefore we put too much nitrogen down compared to what the crop can actually use? So that's important to take note of. Sometimes we may have, you know, quite a low amount of nitrate nitrogen. Maybe we were going for too low a yield goal. Maybe it's because that year we had higher than expected yields based on kind of a perfect growing condition, something we weren't expecting. It could too be that we're having some leaching or denitrification because of excess water on either sandy or heavy clay soils. So again, this is something that can change quite dramatically from year to year. And so being able to watch for that is helpful. I throw this up because this is kind of just a good graphic to show what this variability from year to year ends up looking like. So this is residual nitrate following wheat. This is the trend line or trends from 2000 to 2024 from AgVise Labs, looking at all of the tests that come in from Canada that are following a wheat crop. And there's obviously quite a bit of a range. Now, a lot of this range we expect because, again, it's not going to be the same every year. This is also an average across all of the fields. But you can see after some dry years, like in 2021, we have quite a spike because, again, the crop just didn't take up as much nitrate as we'd expect. They also show the same kind of data in the last 2 years. So it was 2023 and 2024's fall samples, looking at what this looks like in terms of how many pounds per acre are, how many samples are coming in within these different ranges of pounds per acre of nitrate nitrogen. So in a year like 2023, maybe a more normal-ish year, there was quite a few samples that are kind of coming down. Maybe there's more of a range, let's say, of samples that are coming in that have, sorry, let me just say this again. 2023 being a bit drier, having a high number of samples that are coming in with really high residual nitrates. Again, the previous ones we're looking at maybe more of the average, but you can see that we have a big range in terms of where, how many of these high nitrate samples, residual nitrate samples are coming in. Whereas 2024, more of the samples were actually coming in the lower nitrate nitrogen category. So more of that being used up in that year. Okay, phosphorus I've mentioned already too. Again, we are looking at that potential predictability of whether or not you're going to get a phosphorus response. When we look at something like phosphorus, we are using the Olsen test. There are some labs may use different tests, but the Olsen test is the one that is most appropriate for soils that are in the neutral to high pH range. It's also the one that if you are doing any manure management planning, the Olsen test is the one that's tied to those phosphorus limits or phosphorus thresholds, because it is the one that's most appropriate for our Manitoba soils. So there are these different types of tests like modified Kelowna, Bray, and the Bray test, but again, we're not using those tests because they don't typically work for the soils that we have. We can see a lot of variability in soil test phosphorus. It is quite variable in terms of where we take the samples, because it'll vary across that landscape a bit. But recognizing that, this is again why we take a bunch of samples in order to average out that variability. Where we may see soil test phosphorus decrease is if we have high removal crops. So we're growing, say, forages, things that we're taking lots of phosphorus out of the soil, but we're not necessarily replacing it with a whole lot of phosphorus fertilizer or phosphorus source like manure. But also, if we're not getting the same, if we're not taking samples in that 0 to 6 inch range, if we get a deeper sample, we go 0 to 8 inches, 0 to 12 inches, or aren't kind of paying attention to getting a good 6-inch depth sample, then we actually can end up having what looks like a lower test, because we're mixing some of that lower P concentrated soil into the higher P concentrated soil in that topsoil. And that kind of gives a false low number. Same thing on the flip side, if we are sampling just in that top surface less than 6 inches, we may see a higher phosphorus amount, especially if we're dealing with no-till soils where we're not constantly mixing that soil deeper. We may see a higher number in that shallow sampling depth because it's more concentrated closer to the surface. If you're doing that, you want to be consistent then and always taking, say, that 0 to 2 or 0 to 4 inch sample depth. If we have high inputs, manure, fertilizers, if we accidentally hit on a fertilizer band, that might show a higher number than we were expecting. And so we want to recognize that there can be variability. This again is the reason why with annual testing, we can track what that trend line looks like. It might fluctuate ever so slightly year to year based on, that general variability. But with a long-term sampling, we can actually track it if it's going up or going down over time within that little bit of a squiggle, let's say, in the trend line. And then again, when we're looking at phosphorus, we're really looking at these probabilities of response, recognizing, like I showed earlier, if you're in that, 10 to 20 parts per million of Olsen test phosphorus, you have about that 50-50 chance of getting a crop response, which means that at that point, we're in a good position to just be in a maintenance range. So at that point, what you want to be doing is looking at how much phosphorus your crop will remove and maybe just putting down that much. Again, the phosphorus you're applying in that maintenance range is not necessarily going to immediately respond in crop yield the same way that nitrate nitrogen can give you a predictive response amount. But this is, again, just on probabilities. If you're in a very low range, so you're below that 10 to 20 parts per million, here is where you want to be building up, because you'd love to target that 10 to 20 range. Being in the 10 to 20 range on your Olsen test is kind of the sweet spot that we want everybody to fall into, because below that, you have a better chance that you're actually going to have that probability of response. So having more on, or you're going to need potentially more every year, Whereas if you're in this maintenance range, it also gives you a little flexibility considering where we're at right now with high fertilizer prices, that maybe all you're going to do is put that little starter pea down, not worry about whether you're getting the full 30 or 40 pounds per acre that the crop is going to remove, because you have some flexibility to draw down a little bit. And then in a, a lower fertilizer cost year, that's where you might want to put a little bit more to bring yourself back up into these ranges. So that maintenance range is the sweet spot where we love to see people sit, because it gives flexibility, especially when we're dealing with the expensive fertilizer years. If you are in a high range, so you're above 20, that's where you can afford to allow that drawdown to happen. So if you're that high, well, now if you're just using starter pea every year, you might be removing a little bit over time with the higher crop yields. So say you're putting down 10 pounds per acre as starter pea every year, but you're removing 30 to 40. Well, you can kind of get away with that because you're still above that kind of sweet spot. So this little area here in the maintenance range is where people tend to be sitting kind of in the best situation for having that flexibility to make those phosphorus fertilizer decisions more in a more, let's say, reactive manner than having to put down in order to kind of achieve the yield we're going for. And if you are curious about how you find out what that crop removal rate might be, the Prairie Nutrient Removal Calculator, this is released a couple of years ago. It is the more kind of new, I would say, new Western Canadian specific tool that can be used. So you can go in, you can select your crop type. In this case, I was selecting oilseeds. I put in a 40 bushel an acre yield goal for canola, and then it's telling me, or maybe a yield goal, this is where you're kind of back casting. So you can say, okay, this is what I achieved, but for 40 bushels an acre of canola, then the nutrient removal here, and here for phosphorus is the important one, we're looking at potentially that removal of 31 pounds per acre. So with that yield, if I put 10 down, I can assume that I've kind of taken out a little bit more than that, and that might over time start dropping my phosphorus soil test level down. It'll take some time for it to do that. It's not super reactive. It's anywhere from 20 to say 30 pounds of phosphorus removed that is above and beyond what was put down in fertilizer form. We'll take that Olsen test parts per million down about 1 part per million. So again, there's a lot of fluctuation here, but if you're looking at being in a drawdown scenario, that's what you would do. If it was many, many years, you could start to see that come down a little bit over time. Potassium is measured on the exchange site. So it's what we're measuring, the potential for having higher potassium is if you have higher clay content, higher organic matter. Our soils, if they're very young soils, our soils are typically pretty young. They tend to have more clay, or they have more supplying power because they haven't weathered enough to release a lot of the potassium out of that soil yet. We may still get a K response on high K soils if we have compaction or very cool, dry conditions. So we might not think that we need potassium, but sometimes could actually get a response if we just don't have good conditions for that crop. Otherwise, we're looking at likely needing, potash on sandier soils or soils that have low potassium supply potential. So there's also a lot of variability in soil test sampling. Potassium, because it moves in the plant, but it doesn't move in the soil, can be kind of mobilized or moved around in the field. In years when we have canola that is lying in the swath and get some rain on it, that can leach back out, and you may see that impact the following year when you're putting in your cereal crop, where you'll have swaths within that swath area. You'll have these kind of greened up spaces. This is especially will happen on sandier soils that will have less potassium to begin with. On those sandier or lighter soils, you'll end up having these kind of green lines, and that's because the potassium was taken up by the crop evenly across the field, but then concentrated in that swath, and then with that rain, it leaches out of that swath. And then it starts to increase the amount underneath that swath. So then that area has been kind of enriched then with potassium. So that can lead to some of this variability then in that potassium in the soil as well. Sulfur, again, talked a bit about sulfur already. It's very mobile. It is highly variable within the landscape. And it is something that we see go up and down based on how much salinity there then is, because it's a component of the salinity in our soils, in our Canadian soils. Because of that, because it's so highly variable, you'll often have a soil test that will have a lot of sulfate on it. But if you're growing a crop like canola that is highly dependent on sulfur, they still may recommend a sulfur amount, a small amount of sulfate be added. And the reason for that, again, is because of that variability. We want to just make sure that we haven't accidentally overestimated the sulfur by grabbing some of these high sulfate areas within that mixed sample. And so as a result, just as an insurance program, we want to make sure that we put some down for canola regardless. With sulfur, if your soil test says it's low, you trust that it's low. If it says that it's high, you don't trust that it's high. And again, that's just because of that potential variability issue. So again, it's mobile, it will move with water. And so that's where we may see some of these decreases or increases depending on if water is bringing up or down that sulfate sulfur. Again, wet springs can kind of change a little bit of that based on, again, where that sulfur is moving. And so we just recognize that variability means if you're growing canola, it doesn't matter how much it is, we are going to have some little bit of sulfur on that recommendation. And then micros. So our micros, we have different critical levels. There's a big range in terms of what you may have in the total amount in the soil, but what is available, again, is all based on kind of our general understanding of how much supply there might be from each soil. So again, these micros tend to be tied up in organic matter, tied up on clays, on those kind of exchangeable spaces on the clays. And because they tend to be tied up really tightly, there's just a tiny little bit that gets fed out to the crop. Thankfully, micronutrients are only required in small amounts within the crop. And so that little tiny bit, generally speaking, our soils can supply what our crops require. We may have some issues with zinc in crops like corn. We may have issues with copper in some soils, like the wet sand soils, or in organic soils that hold on to these nutrients a little bit more tightly. Iron, again, is one that we tend to have a whole lot of in our soils, but the uptake is not that the soil can't provide it, it's that the plant can't access it. That's more of a plant issue than anything. But again, outside of those, we tend to do really well in terms of micros and having the soil supply everything that we need. Again, there may be recommendations for things like copper, potentially manganese, but zinc. And these are these critical levels that we end up looking at. They are different depending on the type of test that's used. So ANL uses a different extractant. ALS and AgVise, Farmer's Edge, it's not so much ALS anymore. We don't have access to them, but they have a different extractant. And so they then have a different critical level. So that's also important when you're looking at soil tests from different labs, that we recognize that the critical levels can change based on the type of analysis that they're doing. So looking at, just quickly to wrap up, a couple of different potential kind of what you would see from a different soil test. Again, all these different soils labs, they're all doing essentially a similar type of test, or they provide the similar type of information. So they're giving you information in this case, 2 different depths, because it was sent in 0 to 6 and 6 to 24. And then we're looking at these different soil tests. Again, if we're looking at phosphorus, we want to look at the bicarb. That's the Olsen test. That's very important. We can see differences in pH here. And then again, we're looking at nitrate, nitrogen, sulfur, that sort of thing. soluble salts. These are all things that can be on your soil test and should be looked at then. This is an AgVise example, same kind of idea. There's nitrate, nitrogen in the top 2 feet. Olson is automatically reported just in the top 6 inches. It doesn't say it, but these are all done in the top 6 inches, except for if it tells you that it's down to the 24-inch depth. So here again is one of those scenarios where there's a high amount of sulfur, but if we had canola in that recommendation, there would still be a sulfur recommendation for that. Soluble salts are down here, they're low. Carbonates are here, they're pretty high. This is something you want to watch for then in the soybean crop, because this is probably going to have a medium risk of iron deficiency chlorosis. And then this is a test looking again at Farmer's Edge. Similar look, 2 depths, showing nutrients across and looking at just the depths where those 6 to 24-inch depths, so nitrogen, sulfur, chloride, need to be looked at. Electrical conductivity here again, the soluble salts, organic matter, all of that is here, and they give a similar kind of concept of range in terms of whether you're in deficient, marginal, in excess for all of the different nutrients. Okay, so just to quickly summarize, on soil testing, again, it's what we're doing is we're measuring plant available nutrient concentrations. The reason why we look at these different things is because each one of these nutrients or soil characteristics like pH, electrical conductivity or soluble salts, that sort of thing, gives us an idea of what we need to know when we're predicting what our fertilizer requirements are or predicting the potential for crop yield that next year. We have a lot of different options when we're dealing with some of these recommendations, but we have to recognize the soil we have, the soil type we have, the climate we're in, the landscape characteristics, as well as our economic and agronomic goals on the farm in order to put that all together to create that general recommendation. And soil test selection and interpretation is not a one-size-fits-all approach. We recognize that sometimes, annual soil sampling might not be something that you want to do or are able to do, but you can still then tailor the need to be able to kind of keep those good crop records and fertilizer records, yield records, all of that, to be able to watch what's happening over time and do some predictive analysis on, what your soil test levels might be based on all of that. We also recognize that, variable rate, if you're doing variable rate, you may have to have that zone sampling. That's going to be different than looking at, a single rate across the field and being able to do a composite sample or a mixed sample. So you have one analysis for the entire field. All of that sort of thing is different from farm to farm. And so we recognize that there's, different ways of utilizing the information as well as different ways of garnering the information to begin with. So that's what I have for you today. I'm happy to take any questions if they've come up. Otherwise, we may have more questions to respond to with the panel. Thanks.
Okay, thanks, Marla. Actually, one question that came up when you were during your presentation, and it's regarding the year we had this year with the drier year, a shorter crop, but all of a sudden we're getting high yields in a lot of places. How do you feel that's going to affect the amount of fertilizer that may have got used? I guess because we got a shorter crop, is that going to mean less nutrients used, but then the higher yield is going to counteract that? Or
I would say it's going to depend a little bit on the nutrient you're speaking of. So I think that's where that prairie nutrient removal calculator is very helpful. That is just looking at the grain essentially that is being removed from the crop or from the field. That gives you an idea of how much was taken out. What we're not accounting for then is how much was taken up by the crop. And if you're thinking about something like nitrogen uptake, sulfur uptake, that sort of thing within the crop, from the field, we're not accounting for how much went into the residue that's remaining and how much didn't get taken up then. And that's something where having that soil test is really important. So we know that, a lot of the nutrients, they go into the plant, they go into the grain, they're taken off. Something like nitrogen may not have had a huge uptake in a dry year, and then can translocate or be moved into that kind of growing point more easily. And so maybe there's a little less total taken up. But if we had the rain eventually, in order to get the big yield closer to the end of the season, a nutrient like nitrogen that probably didn't move because there wasn't a lot of rain for loss means that some of that still potentially had the means to be moved into the crop for uptake later on in that season. So soil sampling can be really helpful then to be able to kind of track and see how much of what was put down was used. Because if we're not using it all, then that means that there's potential to be able to carry that over to the next year. And that might be really critically important to know then on a year like this year where we're facing some higher fertilizer prices. So you want to know if you have the ability to pull back on fertilization based on not using everything that we gave it this year.
Okay, and another one that just come in, forage crops and pasture, that they've been doing some testing on the nutrients in a lot of those pastures and forages, and they're showing copper deficiency. Would that be because those crops use so much more copper or need so much more, or should we be thinking that maybe we're seeing or could start seeing that in our cereal crops as well?
I would say it's going to depend again on a few different factors. So it could be that deficiency. So sometimes deficiency showed up, not so much the soil is deficient, but because we're deficient in other things like water. So in dry years, we may see some deficiencies that might be a bit of a false deficiency because we just don't have enough water for proper crop uptake. It could be in some soils that have a high potential for copper deficiency, that deficiency may be coming up as a true deficiency, and we need to look at being able to provide a little bit of copper. Typically, we see these things on the Al-Mississippi soils, the areas that have kind of um, those wet sands, or in high organic soils, we may have some of those copper deficiencies show up, and it's something to keep an eye out on crops like wheat, that you see this kind of pigtailing impact. But it's definitely something to keep an eye on. And if anybody has questions about that, they can always reach out to me and we can kind of work through what they're seeing in the soil test versus that tissue test.
Yeah, and we did see some pigtailing this year, and I think we had it on one of the earlier crop talks.
Okay.
Okay, I'm going to go right to this crop scouting panel. And Marla, all the questions are going to be for you today because it's a fertilizer day. And uh, our soil temperatures, I just took the Brandon one last night here, and it was 13, 12, 13, and 12 for, from 5 to 100 centimeters. What temperature should producers be looking at when they go out to start fertilizing? We see a lot of anhydrous tanks being towed to yards right now. I think guys are getting ready to start. What's your recommendation there?
I'd like to see them hold off as much as possible. Prefer to see soil temperatures down below 10. And 5 is even better. So essentially, the reason why we say that is because nitrogen loss tends to occur because of biological activity, and biological activity slows when that soil temperature is below 5. If you think about, the fact that we keep our fridges below 4 degrees is to decrease things like bugs growing in our food. And so the lower temperature, the better. That being so, the rule of thumb we usually say is to hold off until Thanksgiving, and then get going. Fertilizing too early just has that potential for higher risk of loss. But we are in a very warm, uncharacteristically warm period right now. So our soil temperatures haven't started to drop as deep as we would like them to. If it's possible to hold off, that would be recommended. If it's not possible to hold off, then this is where having some kind of inhibitor can slow down that process of change. So say on anhydrous, if you've got an inhibitor that's going to decrease, like that nitrification inhibitor, to decrease the ammonia being transformed into nitrate, that's going to buy a bit of time essentially before more of that to slow down that potential for the microbial activity. So that's why those inhibitors exist, is essentially when we have to go in times or places where we're not kind of ideal, to be able to slow down that potential process. But I would really like it to get a little cooler before the fertilizer starts getting down.
Okay, another question just come in for N requirements. Do you take into account any losses over the winter or
Mm.
assume that most of the nitrogen shown on lab results are available?
So typically we'll make the assumption that it's going to be available. And the reason for that, but that will also depend on where you're at, what your field is like. And this is where having your own kind of knowledge about the soil type and understanding what's happening with the weather is going to be important. So if you have, let's say a heavy clay soil and you get a lot of rain after, and you have warmer soil temperatures with a ton of rain after soil sampling, we can recognize that there might be some loss of denitrification, so that loss to the atmosphere from some of that soil nitrate. Similarly, if we have a lot of rain on a sandy soil, we expect that there might be leaching from that point on. And so that may come into effect in terms of a potential loss after that soil test has been done. We often will recommend soil testing also later in the fall, again, after the soil temperature has dropped down such that you won't get a lot of that biological transformation happening anymore. So it's more likely that soil test will stay accurate into the spring. However, there's only so much time in the season. And so going in and sampling a little earlier can allow for more time for that analysis to get done, and also for you to use the analysis in your fertilizer decisions. So we recognize that sometimes we're going a little earlier. There may be a bit of a fluctuation in that, in potential loss, but that all will depend on what happens with the weather. And again, that is really not that predictable always for us, but it is something that can potentially happen.
Okay, and one more here. I'm getting some calls and questions regarding cover crops, and as they're becoming more and more talked about and popular, how much nutrients get used up by that cover crop in the fall, and are they going to be available again for next year or next spring's crop?
So, I mean, cover crops can be really great, especially if you have some residual nitrogen and expect that you may have losses, or have, high potential for loss, to kind of tie up that extra unused nutrient. And that's actually a positive thing environmentally if it's tying it up to keep it from leaching if you're on a high leaching potential soil. Now, that being said, for the next year, we don't always know how quickly it will come out, because that cover crop needs to die, decompose, and then that nitrogen has to be remineralized, mineralized back out of that crop residue, the cover crop residue. And that is less predictable. So we can't always predict that cover crop nutrient release from the nutrients that they do come out will come back out again that next year. And so it's a bit of a tricky one. And it's the reason why we don't always trust mineralizable nitrogen, even in a soil test either, in our soils here, because of the fact that there's so much variability in that weather on whether or not you're going to have enough warmth, moisture, all of that, to have that mineralization happen. So a lot of the kind of recommendations coming out of some of the research is to not necessarily count on that nutrient taken up, say if you had one growing this fall, that it would be released next year. It will be released again. It just might not be released specifically in that following year. Cover crops can have potential benefits, especially if we're dealing with some wet conditions and you want to dry the soil down, so they can kind of take water out of the soil, which can be really helpful for kind of creating a better situation for seeding into next year. In terms of whether there's a specific mix that's better than the others, I wouldn't necessarily say so unless you were trying to create nitrogen and you want, a legume in that cover crop mix. It depends on what you're trying to do. Things that have more tap roots in them will help potentially to push down through tighter soil and maybe alleviate a bit of soil compaction. More grassy, fibrous root systems can really extract and take up a bunch of nutrients because of the way that they kind of explore the soil. Sometimes if you're looking at the use of a cover crop, the best cover crop is the one that's already growing for you. If you have a lot of regrowth from, harvest losses and let that grow, it can take up the extra nutrients, it can take up the extra water, and it's great because it's the cheapest one available to you because you didn't have to seed it. So cover crops come in all shapes and sizes, and so they have a lot of different potential purposes, but that can change a lot based on your soil type, your situation, and what you're trying to achieve. But hard to assume in our kind of prairie climate that the nutrients that they take up in the fall are going to be available immediately the next year.
Yeah, I think we maybe learned some of that when we first started with zero till. We were seeing that maybe in some crops by later in the fall, some of those nutrients maybe were becoming available, but not in the spring.
Yeah, exactly.
Great. Thanks, Marla. Great presentation. And you were able to answer all the questions I had. So thanks again for the presentation. And we'll just conclude today now with a few more slides. Again, here's the crop production extension specialists, our locations and our phone numbers. So if you got questions, if you're seeing something out in the field, I know there's been a few things pop up, and as producers have been out there harvesting and now maybe getting some time to drive over some of those fields and noticing things. So if you got any questions, definitely give us a call. Our livestock people, there's their contact information as well. We're starting to see a lot of corn silage come in right now, so it's be good to get some quality or figure out when is the best time to sample those piles for getting what your feed analysis is on that. The Manitoba hay listing service, the number it's there, as well as the crop residue burning. Oh, and before I forget, Marla, that slide you put up that had the fertilizer calculator there. Where did you find that?
Oh, if you Google prairie nutrient removal calculator, then that should be the first thing that pops up there. So it's a pretty easy one to find. So
Great,
prairie
thanks.
nutrient removal. Yep.
Great. The MASC service centers, the two new offices that just opened up, their numbers are on there. On the bottom, Shoal Lake and Verdon. So if you've got questions, make sure you get a hold of them. Question came in is where can we access the webinars or presentations after to rewatch? They'll be on our Manitoba government website. Under CropTalk. If you do that as well, if you're registered for CropTalk, you'll be getting a link that Lori will be sending out later today of the webinar, and you just have to click on that and you can watch it again there. And one more slide here, I think. Yeah. So thanks for attending. Thanks for Marla for giving all that good information. And by next week, crop production report will be coming out this afternoon sometimes. So join us next week, October the 8th. And I think we'll be talking about harvest being completed in most areas. So thanks for attending and see you.